Welcome back. This is part 3 of our video series on section 5.1, angles and radians. We just finished talking about how to convert from angles to radians, and I realized I missed an opportunity to say something pretty important about that. Honestly, the best way to convert between angles and radians is just to do it so often and so much that you become really, really familiar with them. If you can get to the point where you're sort of thinking in radians, and like when you see an angle you just imagine how many radians it is, that's going to make that sort of level of procedural fluency in using these radians is going to make doing the math for the next few sections really much easier, much nicer. If you have the time to just spend half an hour even just like working through different radians and degrees, and kind of like maybe make flashcards, like put 135 degrees on a flashcard and then flip it over and it says 3 pi over 4 radians. Like, if you can just give yourself that level of like fluency going back and forth between the two, it'll make the rest of this section much easier. So that is my advice. I hope you take it. The last two things we need to talk about that aren't moving back and forth between radians and degrees are position, which means we're going to put angles onto coordinate grids. So, when we put angles on the coordinate grid, the thing to keep in mind is that you always start here at the positive x-axis. Always start here on this thing, and you go counterclockwise. This gives all of these angles sort of positions. So anything between 0 and 90 degrees ends up being a quadrant 1 angle. 45 degrees is right in the middle of quadrant 1. 60 degrees is kind of more north and less east, but it's still in quadrant 1. 90 degrees is straight up the y-axis. This is a 90-degree angle. That's pi over 2, we said. So 90 degrees isn't in a quadrant. It's on the positive y-axis. Anything between 90 and 180, so if you're coming over here, this is maybe 135 degrees. That's 3 pi over 4 radians. Anything between 90 and 180 will be in the second quadrant. Anything, this is 240 degrees down here, we'll say. That's 4 pi over 3. Anything between 180 degrees and 270 degrees, that will be in the third quadrant. 180 is straight back, that's the negative x-axis. 270 is straight down, that's the negative y-axis. And I'll squeeze the last one in here. Anything between 270 degrees and 360 degrees, so like maybe this is probably 315 degrees right here. That's 7 pi over 4. That's a 4, trust me. Okay, 7 pi over 4. Anything between this 270 straight down negative y-axis angle and 360 degrees is all the way around back to the positive x-axis. Between those two will give you angles that are in quadrant 4. So some of you might be wondering at this point, what if I have angles that aren't between 0 and 360? One of the video games I grew up playing was called 1080 Snowboarding. And it was called 1080 Snowboarding because 1080 is the number of degrees in 3 full rotations. So if you're on a snowboard and you can do a big jump and spin around 3 times on the snowboard, that was like the best trick you could do in that video game was a 1080. It means jumping into the air and getting 3 full rotations on your board before you land again. So these angles that are bigger than 360 definitely exist, and we need to talk about them. And to talk about them, we need to have an idea of something called coterminal angles. So we already said that 45 degrees, which is also known as pi over 4 radians, is in the middle of quadrant 1. We should also talk about what happens if we go all the way around and then come back to 45 degrees. This angle is 405 degrees, which is 45 degrees plus 1 full rotation. And the relationship between these two angles, which end up in the exact same place, this relationship is called coterminal. For those of you that enjoy Latin and/or Arnold Schwarzenegger movies, you might know that terminal means end, like the Terminator. He comes to end things. Co means together. So coterminal means the two angles end together. They end in the same place. So if you start spinning around the axis, if you end at 45 degrees, you're here. If you end at 405 degrees, that puts you in the same place. Because it's the same position, you've just gone around the circle one extra time. The same could be said of, let's call it 765 degrees. That's what we get if we take this and just add another 360. The same could also be said, so 45, 405, 765, these things are all coterminal. The same can also be said of negative 315 degrees. What on earth is a negative degree? What does that mean? I'm glad you asked. Dave's face in the camera. Negative 315 degrees means we're still going to start on the positive x-axis. This is always where you start. But we're going to go clockwise instead of counterclockwise. We'll go clockwise up to here. If this is negative 315 degrees, that means that this little piece that's left is still 45 degrees, and that's still coterminal. We can get this by doing 45 degrees minus 360 degrees. That'll give you the negative 315. So the moral of these coterminal angles is, for any angle you have, 45 or 405 or 765 or negative 315, whatever angle you're starting with, you can always add or subtract full rotations, plural, more than one if you want to. Like you can always subtract one, or you could subtract a bunch of them, or you could add one, or you could add a bunch of them. Any number, positive or negative, of full rotations, you can add or subtract to an angle, and you will always get something coterminal. Because if you're adding or subtracting full rotations, you're guaranteed to end in the same spot. So, for degrees, to get something coterminal, you should be adding or subtracting 360, because that's a full rotation. If you're doing this in radians, you need to be adding or subtracting 2 pi. And the very exciting thing about adding or subtracting 2 pi is almost all of the angles you'll work with using radians start as fractions. So when you add or subtract 2 pi to these fractions, you have to use fraction arithmetic. I hope you remember your fraction arithmetic very well. It's going to come up a lot. This one, for example, if you started with pi over 4 and you wanted to add 2 pi, you have to sort of swap out this 2 pi for 8 pi over 4. You have to get a common denominator before you can add these things. And what you end up with is 9 pi over 4. So, coterminal means you're adding or subtracting any number of full rotations, and If you're doing that in radians, when you add or subtract those full rotations, you have to have a common denominator. That's going to do it for these videos. That's pretty much everything you will be encountering in the section 5.1 homework. So I hope that was clear. If it's not, come find me in the ASC. I would love to work with you about it more. And until next time, this is Dave signing out.